All right. I'm very conscious we're short of time, and we've still got Ali, Kashani, and three other speakers. So Ali, I'll hand over to you for quick fire questions and hopefully some short answers to cover the breadth. Performance seems to be one of the key words that I've heard from each speaker today. So with that, segue over to you. Thanks very much, Ali.
Thank you so much, Hudson. Just a short introduction of myself. I'm assistant professor at University of New South Wales and also founding director of Syncrete, concrete made with CO2. First, let me thank Kathy, Monica, and Deepali for co-organizing this event. And also thanks to Hudson for chairing this event and our distinguished speakers and panelists of this session. And also special thanks to the MECLA Cement and Concrete Working Group for their special contribution to the discussions that we have led to this event. So Margie mentioned about the performance-based specification as a part of the cement and concrete decarbonization pathways, and Steve and Cindy just touched on those, that there is a need for such things. So what is the performance-based specification? So in that specification, compared to the traditional standard and prescriptive specification, we set a acceptance tests and criteria. So based on that, all the stakeholders, case by case, in a collaborative environment, can look at those tests and criteria that needs to be set and tested during the time of a trial or etc. And those stakeholders can be suppliers, asset owners, specifiers, and other stakeholders. So, but it's not that easy. There are a lot of risk involved and there are lack of long-term performance data and other challenges. And that's the reason at MECLA, we created a special task force to identify issues, roadblocks, risks, and concerns with regards to transition to performance-based specification. So today we are going to hear about some of those challenges from some of the key stakeholders that we invited, in addition to our speakers today. So our panelists would be Harish Srivastava, Director of Civil Engineering at Transport for New South Wales; Jason Nairn, Director Research and Technology at Cement Concrete Aggregate Australia; and Michael Kemp, CEO of Earth Friendly Concrete at Wagners, Australia. So let me start by the first question from Harish. Harish, if you're there, I just wanted to ask, from the perspective of an infrastructure asset owner at Transport for New South Wales, what would be the main risks and challenges to adopt performance-based specification, and how these risks can be mitigated? Over to you, Harish.
Hi, Ali. I think probably good afternoon, everyone else. I think the question you have asked, if I have got the 100% answer, then probably there's no need for any research and there's no need for MECLA special group. So, but I guess when I think the performance-based specification, we have been talking about it, but probably the main constraint is how to assure various mixes. And there's no framework exists, at least to best of my knowledge, that can predict any new mixes or any new sustainable mixes, which is and related back to some of the existing constitution of the concrete or existing mixes. So unless that sort of a framework is there, then basically it becomes very hard to assure that piece of concrete, because like transport infrastructure are designed for 100 and 120 year design life. Some of the existing transport specification has lived for a particular, means a long life now, and various modification has been made via the trial and error. As people sort of found the thing, they kept adding it, though sometimes it becomes quite onerous. But when we are talking about performance index, for example, just now Cindy sort of said, if you just specify 70 kilo per cubic meter of concrete, carbon footprint, and then basically people, then everything is open to the designers. Then I guess it comes down to how that mix will perform in short term and long term, and how that will fulfill the structural requirements. So I guess that is the biggest question. Probably we need to find for which an answer needs to be yet to be found. And once we find that answer, basically, and that particular type of framework, which can be either in form of a standard or a guide or whatever, if people can follow that standard or guide, then probably they are confident that there's a validation. So I think that is the missing link before we can actually find the good application of this performance-based specifications.
Thank you so much, Harish. I think that's a very good answer. I have a few more questions to ask, but I'm just concerned of time. So I've got a similar question for Steve as well. So Steve, what are the roles of academics and universities in transition to performance-based specification? And would performance-based specification help in accelerating innovation in developing low-embodied concrete materials and structures, some of those examples that you mentioned in your presentation?
Yeah, look, Ali, absolutely it would. And we've got to get this handbook out for that reason, because we need to move it on from a handbook then into standards. But you ask where universities can assist in this. And one of the things, other than just looking at, say, the performances that are needed. So we've got to absolutely get away from saying, for example, you've got to have X kilograms of cement in a concrete for durability, to saying we've got to have a carbonation rate of Y. You know, you've got to put the performances in. Then we've got to have the tests in place, and we've got to validate those tests. So I think this is where the universities can come in. I'll give you an example. So the test for carbonation requires 2% carbon dioxide concentration. It's an accelerated test. 2% carbon dioxide concentration doesn't work with geopolymer concrete, because it changes the nature of the concrete. It actually interacts and changes it itself. But 1% works really well. So through the research that we do through those tests, we can also look at assisting in monitoring and working with industry and developing of new products. As I think I said, it's not going to be one thing or other, but also it doesn't mean that if we're going to a particular product that we should use exactly the same as we have in the past. We should look at the whole of the technologies. It might be that we use them in different ways than we have in the past. I think this is where industry and researchers can get together and work together on these applications.
Sure. Thank you so much, Steve. I think we can definitely get back to this from cement and concrete supply, but I wanted to continue discussion with other panelists from cement and concrete supplier point of view. So we have Michael, Jason, and Margie from concrete and cement industry. So maybe I've got this question for all three of you, but maybe we can start with Jason and then move on. So from cement and concrete supplier point of view, so how performance-based specification can help with market penetration of those non-traditional low-embodied carbon cement and concrete from your view?
Thanks, Ali. So I suppose just a quick one about performance-based versus our normal prescription-based specifications. So prescription specifications, as Steve said, are a set of rules to provide and guarantee then the concrete with traditional materials are going to meet the plastic, hardened and durable concrete properties. And that works really fine. That works fine, but it's not the most efficient and does exclude certain low carbon cements and concretes from being used. So moving to performance-based is really about replacing some of those prescriptive elements. Maybe it's minimum cement content, maybe it's limitations on the type and amounts of SCMs, maybe it's on binder type. Replacing those with performance-based characteristics that we know are related to the derogation mechanisms, because certainly we can measure the plastic properties, their fresh concrete properties, we can measure the hardened properties, strength and shrinkage and creep quite quickly It is the durability that limits us in regards to performance-based specifications. So it's understanding those degradation mechanisms, and Steve mentioned about carbonation and the effect of that, and that's really about the concrete provides an alkaline environment that protects the steel from corrosion, underlying steel from corrosion. And once we understand the degradation mechanisms, is modeling that and then having a concrete property that is input into that model. Unfortunately, we can't wait 100 years to measure that concrete property. We do need to use accelerated tests, but we do need to make sure those accelerated tests are appropriate. They replicate the mechanism that's going on in the natural unaccelerated environment, and therefore can be used into those durability predictive equations. And we do that for quite a lot of things already, for chloride ingress, for instance, in marine exposures. But what's going to help us really is research into the degradation modeling. It's research into the methods by which we measure the concrete properties in an accelerated way. It's research into in looking at structures that are out there already and understanding those. And it's research into the concrete mixes, low carbon and otherwise, that can be made to seat those performance requirements. And again, as Margie said, it's a whole value chain. We've got to have the final clients, say Transport for New South Wales and Harish and I working on a project together with Smartcrete, hopefully, and on this exact topic. It's working with the constructor to understand that these new concretes that meet performance-based will look and feel a bit different. We'll have to change the way we handle them and pump them and place them. It's working with the universities, the research bots, and obviously then the material supplier. So it's a big, if I would just change the specification, it sounds quite simple. It's a big project, Ali. You started this with me and the 5B team with performance-based specifications. It's been going on around the world since I first graduated, and we've got some way to go. But as Steve said, we do need to accelerate our activities in this area. So that's my answer.
Thank you so much, Jason. Michael, from your point of view, so you have the earth-friendly concrete, which is a geopolymer-based concrete. And I guess that you also have the challenges in terms of the penetration into the market and the standard, etc. So what's your point of view on performance-based specification and how it can help the market penetration of your products?
Yeah, thanks, Ali. And it's obviously the critical way to go if you're specifying a minimum cement content. It rules out zero cement concretes. Additionally, once a contract is let, if it gets to a contractor, I think Cindy alluded to this, they just don't have the time to be able to drive those changes or to do investigative work. So I think a lot of the work has to be done prior to engagement of a contractor, or have a component of time where it is, a requirement of the contract to do this investigative work. From the specification point of view, I think Steve Foster hit the nail on the head. Rather than sort of say a percentage of cement or a maximum percentage of cement or a minimum cementitious replacement, talk about the properties you're after. If it's a carbonation property, let's talk about what's the requirement. If it's a chloride ion ingress, let's talk about the requirement. And that takes a bit of thought. It takes a bit of, vision. It takes engineers that aren't just following the code directly. There are risks, of course, there, and legal risks that come into account. So at the end of the day, it'll come back to asset owners, I think, to drive this. They'll need to say we want to make a change, and that they need to push that supply chain. Supply chain needs to be willing to come along for the journey. My background, Ali, at Wagners for the last 20 years has been bringing the composites business to reality. We started off with nothing, and we've now built that wharf that Stephen talked about, as well as other a lot of other structures around the world in the road networks in the USA and Australia. The biggest advantage the composite business had is that it's not so close to another code that it could be used. I think that one of the issues certainly with bringing geopolymer to market is it's so close to normal concrete, but not quite. So people are trying to push it into the normal concrete specification, which makes sense for a lot of it, but it's also something we'll have to overcome.
Thank you so much, Michael. And I would ask the same question from Margie, but probably a little in different environments in the cement industry, not just focusing on concrete and concrete specification. I also know that there are some limitation in terms of the cement production. And how do you think that those limitations based on the standard can be changed or can be removed in order to use new type of low carbon cements? You're on mute, Margie.
I'm not doing very well today. I do have COVID, by the way, so please excuse me. I might pass this question over to Jason to answer. I think that he can speak from a more technical perspective.
Jason, do you want me to repeat the question? I think that's okay. We can just move on. I have, if we got time, I've got one final question, and hopefully we can extend this session so we can also.
Let's do that. Apologies, everybody. We've obviously had some IT troubles at the outset, but the conversation is important, and we've got the experts assembled. So if you have the time, please stay on. We'll go for another 10 minutes to 3:40. Ali, keep going, please. Thank you, mate.
Thank you so much, Hudson. So this is my last question, and then I'll go through the questions from chat box, and I will try to answer as much as possible. If not, we keep the questions recorded, and hopefully we can get some answers from our panelists. So that question is for everyone if you want to jump in and answer. So how federal, state, or local government can play a role in transition to low carbon construction through performance-based specification or other tools? So how government at different levels can help with this?
Is that an open question to anyone, Ali?
Yeah.
Yes, please go ahead, Michael.
Yeah, we're obviously working. We've been working with state government departments for a long time, and it's about sort of that willingness to trial. And a lot of, particularly the government entities, are sort of for many years, and it's probably political as well. They lose the sort of desire to try something new, and then all of a sudden it's a rush, and we need to do this. So as a product supplier, we're trying to, gauge our response depending on the demand that's there. But if to be honest, it's the time. Typically, government guys, in whether it's in Transport New South Wales or Queensland Main Roads, they're trying to not be on the front page of the paper. So it is a conservative approach. I feel that there's probably a requirement in state organisations for them to have people that their job is to investigate new technologies, to work with universities to be able to assess them, and it's actually part of their remit to bring new things into projects. Without that, the average sort of from the state response and this is limited to my experience the last 20 years, but the typical response is, that the thing to do is to follow the code, we'll get an outcome. But it doesn't drive new materials, whatever part of the industry they're coming from.
Thanks, Michael. Is there any other comment from the panel with regards to the government push?
Ali, it's Margie speaking. I think going back to the VDZ report and looking at all the various pathways, that we need to look at right through the value chain, and what our operational emissions do become and what our embodied carbon emissions are. And so the role of government at all levels is really critical, both at a federal, a state, and a local level. And there has been an increased awareness, and I think a lot of conversation that has been happening that previously has been ignored. And we've seen some real leadership across many of the state governments as well. Procurement is obviously a really critical way of being able to draw through that demand response in terms of trying to draw through lower embodied carbon product, just as it is, for example, in trying to use alternative fuels down at the facility and making sure that the EPAs have a good understanding of new waste materials that could be utilised and how important they are to be able to get access instead of them going to landfill.
Sure. Margie, while are you here, we had a question specifically from you during the registration, and it said that what would be an effective government policy that could increase demand for low carbon concrete, and why we should be confident about the 33% reduction emission using CCUS when the industry is arguably slow to start. And I think that part of that is also come with is there any contribution from the government or for such a huge investment project type of projects?
Yeah, I'll start with the latter question first. With regards to CCS, CCU, when we're looking at what technologies are available now or are likely to be available during the time period at the moment, we need to rely on CCS or CCU to fully decarbonise. However, there are many new technologies that are starting to come into play that could change the VDZ report. Remember that this is an independent report looking at what are the pathways that if we're looking through that lens today, that may differ in 5 years' time. But it is very difficult to see how we can fully decarbonise without CCS, CCU. And I think you would be surprised at just how many pilot projects are going on at the moment across the world. I recommend going onto the GCCA, the Global Cement and Concrete Association website. If you just type in GCCA and then CCUS, you'll actually see a mapping of all the projects internationally that are underway, that are piloting. And Stephen mentioned the Nordic project that is underway. They were a first mover. And other countries have then trialled parts of the CCS mapping, and costs are coming down really quickly. We're quite surprised at how quickly the costs are actually reducing. So it's not a preferred technology, but it's not something that we can rule out. In terms of government policy, I think that's a really long conversation. It's discussed in detail in the VDZ report. Government plays a key role, as I said, across all the various parts of the value chain. Behind any technology or any type of policy change, there's usually regulation. And it's really important that governments can keep up with that. But as we know, governments are also they're not just customers, they're also investors. And the support that's being provided at the moment to accelerate change has increased dramatically. And I think the relationships and networks that are starting to form across the value chain are something that we haven't seen before. And MECLA is one of those key initiatives that has played a really key role in just in terms of networking, for example, and not to mention the great work program that's going to be created from the MECLA initiative.
Thanks so much, Margie. Michael, we have a registered question of probably, I think that's from you, and also Steve, you can also comment on that. So the question says that binders like geothermal have a low market penetration so far, even though it has been studied for almost half a century, or maybe a little bit less than that. So what's your response on that?
The low market penetration, we've put it down to, I guess, having a product that's ready. So we did our first test tube, I was there for it, in 2007 at Wagners. We've done multiple trial projects along the way. We've focused on sort of precast building elements in the early days. And it's all been about gaining control of the concrete. So if you can't control the concrete, control the environment, hence precast. We've The current position, however, is that we are manufacturing concrete every day in Brisbane and in London through our partners over there. So we're supplying through Capital Concrete in London into foundations every day. So we're seeing it ramp right up. And it's as two things are happening. Demand is growing, and the amount of testing we've done, and I guess our ability to show performance has increased. So I guess since 2007, we've been building a database of testing and building our, I guess, portfolio of projects that we've been able to deliver. And that generates confidence when we go to talk to people about the next project.
And Ali, can I just add to that, Michael? And also, just before I answer that question, Michael touched on it before, as did Margie, the importance of the government business enterprises and the government departments in this space. Whether they like it or not, their codes are being used by others. And when their codes are restrictive, it's restricting others as well. They've got a huge potential to drive change. Getting back to the question here at hand about penetration, I think the big thing here is till now, we've really not had a price on carbon. And concrete technologies, what they are relatively cheap for a long time. And there's been no driver, there's been no need to change. Well, that's changing. We are talking a lot more. And of course, there is a cost on carbon. It's the cost of what happens in the atmosphere if we don't do something about it. But whatever that mechanism is, whether it's state governments dictating on carbon emissions, there will be a cost there. And when that comes in, other technologies which have been prepared, as the questioner said, dual polymer concretes have been around for over 50 years. There's examples of them produced back in the 1950s and 60s elsewhere. But in the last 20 years in strength. That these technologies, and it might not just be, we shouldn't just be talking about, these alternates. There'll be other products that come onto the market. There'll be other materials potentially from other waste sources. We talked about mine tailings. We know glass is another area as well. It's been heavily researched. You're aware of that, of course. So there'll be other products that come onto the market when the carbon is properly priced, whatever that mechanism is.
Thank you so much, Steve, and thank you all presenters and panelists and all the audience that's come today. So I apologize that I cannot go through the question because we run out of time. So Hudson, over to you. Thank you.